Welcome to CSEC Biology, the cover page. In today's lesson, I'll be showing you how to write up the labs for your Science CSEC SBA. The lesson is ideal for students in grade 9, 10 and 11 who are doing the CXC CSEC Sciences anywhere in the Caribbean. We want to show you Appendix 2 of a new HSB syllabus that is effective for exam May-June 2022. It means that students who are in grade 10 now would be using that syllabus. Let's look at the activity on Appendix 2. So this is Appendix 2 and it carries a number of practical activities that are to be covered for the Human and Social Biology syllabus. These are not the activities that will be assessed for the SBA, but of course these activities could be found or will be found on the examination paper. The SBA component, as it were, for Human and Social Biology will take the form of a research. Now in today's lesson we are going to be covering diffusion, and we are going to be specifically looking at the diffusion of solid in liquid. So stay with us for the next couple of minutes, and at the end you should be able to write up your SBA labs. The task, we're supposed to carry out an experiment to show a solid diffusing in liquid. And of course, I'll be showing you how to write up the SBA lab for the CSEC examination. The skills that we want to look at primarily will be measurement and manipulation, observation, reporting and recording, analysis and interpretation. Before we get into the lab, we should be mindful of the fact that the rate of diffusion is affected by temperature, particle size, concentration, and of course wind speed, and that will be shown somewhat in our experiment today. When writing up the lab, the first thing you want to make sure that you know what lab number it is. Please be reminded that you can go to any one of my videos on writing up a lab for any of these skills and get further information as to the requirements when you are writing up the SBA lab. But let's look at this lab. So you need to know the lab number, you need to record the date the lab was done, you need to also record the title of the lab, and of course you need to have an aim. Now if you observe here, the aim begins with 2. To determine how temperature affects the rate of diffusion with solid diffusing, of course, in a liquid. And the skills that we are looking at is ORR, MM and AI. Now please be reminded that the students are not to be assessed on more than 2 skills for any particular experiment, but for the purpose of demonstration I am using 3 skills here. After we would have written the skills, it is now time for us to write apparatus and material. Please bear in mind, apparatus and material, they are not the same thing and they should not be used interchangeably. Apparatus refers to those things that can be reused in the experiment, as it were here: beaker, measuring cylinder, spatula, thermometer, refrigerator, microwave, stopwatch, petri dish. However, as it were for this experiment, the potassium permanganate would have been considered to be a material. Now a good material would have been like a filter paper. Once the material is used, it is thrown away, it's not used again. So after our apparatus material comes our procedure, and usually you are given the procedure in future tense, but you are expected to write the procedure in past tense. So you'll observe here the white writing outline what you are supposed to do And of course, this will be given to you by your teacher, or it might be found in your school's lab manual. I'm not too sure what the case is for you. So here we have, of course, the procedure on 2 pages. There we have it well outlined. You can pause the video and read, and of course at any time you can start the video over and over, however many times you so desire. Now this is how you are expected to write up the procedure. The procedure must be written in past tense, and of course your procedure should follow a clear sequence that anyone who picks up this lab, they are able to execute with the procedure you would have given. Ensure that the grammar and the English is proper, more so when observation, reporting and recording is a skill being assessed. Now you'll see measurement of 200 ml. Remember that we are using the SI unit, and I ask you to just go on over to my video on finding volume to understand better how you will be assessed for the mm scale. So here we have our 2 slides. These are the slides that you'll be writing, and the black writing here suggests that it has been written now in past tense, just the way you are supposed to write it. Now right after our procedure is going to come our diagrams, and the diagram represent the setup of the lab that you are doing. Here I started it out for you to complete it if you are going to be using the experiment that I have, but more so for the human and social biology students, this would be good practice for them because they are new to this arena. It's the first time they are ever going to be doing human and social biology, so I have to be a little slower, more accommodating with the kids doing HSB. Now we are going to break and move to the video. Please ensure you have your pen, pencil, paper, that type of a thing, so that you are able to record your observation. Remember, it is your observation, so you want to ensure that you are recording it and recording it properly. Please feel free to stop this video at any point, and of course to start over until you understand and the observation is clear to you. If the observation is not clear, then your aim will be a problem, because you will not be able to write a good conclusion, neither will you be able to write a good discussion. Let's move on into the video. So we see that specimen B is totally purple, and that happened at 1 minute 33 seconds. While we're still looking at the other 2 containers, the temperature is pretty close. Temperature here is 28 degrees Celsius, and over here the temperature is 22 degrees Celsius. We are 2 minutes and 38 seconds into the experiment. This is of course a diffusion experiment, so we are having a view from above. We're trying to look through the water column just to see how fast the rate of diffusion would have taken place in the hot water versus cold water versus room temperature water. So I'm sure based on what you're seeing, you could make a decision. I think you could clearly say how temperature impacts the rate of diffusion. Now, this is very, very important, because if you're going to be applying any pesticide, aerosol, then it pretty much dictates how fast it will move on a hot day versus how fast it will move on a cold day. All right, so this experiment is really, really important. Really important. It's a very important part of your CSEC syllabus to find out about diffusion and osmosis. And today we are working on diffusion. We have just used potassium permanganate with 200 ml of water. Temperature 22 degrees Celsius, 89 degrees Celsius, and of course 28 degrees Celsius. And like I have said, this is the COVID response to experiment. We are home, we're doing the experiment at home, I have some makeshift container here. They are just simply some little soda bottles. I actually use the scissors to cut the top off and to get the experiment going. But I did do some measurement with some measuring cylinder I brought from work. So I'm sure that the volume of water is pretty constant across all. Same to the amount of potassium permanganates that we're using for the experiment. And of course, we're not using a stopwatch as would have been in the lab. I'm using the stopwatch on the computer, and you can see it. I'm just right here looking at it, monitoring the experiment. And from what you're seeing, I'm hoping that you'll be able to write up this lab. Right, so we have used a beaker. We're using some modified beaker. We've used measuring cylinder. Of course, we use a balance to find the mass of the potassium permanganate. I'll soon tell you that. And we have used a spatula to actually get the potassium permanganate onto the paper. And of course, we use the microwave to heat up the water, and we had to use the refrigerator to lower the temperature of the water. And we just got specimen C from the pipe. And you remember it is at 28 degrees Celsius. Remember, you're going to be keeping your measurement in degrees Celsius, as we are going to be paying close attention to the SI unit. We're not going to be working with the imperial measurement. Remember, the syllabus requires you to work with the SI unit. And you would remember that for temperature, it is going to be Kelvin. So you want to hop on over to my video on measurement and manipulation. You want to look at that video we have there for temperature. The formula is right there, so you can convert degrees Celsius to Kelvin, because Kelvin is of course the accepted unit. Now, many laboratories in Jamaica, they are still with thermometers that might be degrees Celsius and might be Fahrenheit. But pretty soon we might make a change. It takes a little time for everything to change, but I think we're still doing well where labs are concerned in school, and I hope that students are really understanding the importance of using the SI unit versus the imperial measurement. We're still looking at the water column. We're 7 minutes into the experiment, and of course you would have seen the 89 degrees Celsius. That water is pretty purple, like probably you would want to see a grape soda. Unlike the others, they look like they haven't been given much potassium permanganate. But of course, remember, we are looking at how temperature impacts the rate of diffusion. Now, if you're a chemistry student, you would remember that matter is pretty much in constant motion. And when matter becomes energized, you know that the movement is even greater. Now, if you're a physics student, you'd have an appreciation for that. You'd understand why the light wires have that sag. You'd understand why the train line has that space. You'd understand why the bridge on the road has the space, because the thermal expansion. So we have an appreciation pretty much for the work that temperature can do, how it can cause things to move very fast, very quickly. So we have to be very careful when we are working with the temperature, heat. It can really do some amount of damage, and it of course can do some amount of good. Even when we are working with things like liquid and gas, we made mention of some solid just now, but just look at what is happening in the container with the liquid and the potassium permanganate. There's a little movement here. You can see the potassium permanganate settled pretty much at the bottom of the container, and here you can see the potassium permanganate is all it has all diffused through the water column in this specimen with the hot water. And over here, the specimen from the top, wow, look at it, little or no movement. But we have to make a decision. So from what you're seeing on the video, after 9 minutes, this is what specimen C looks like. That's specimen B, and you can see the temperature there. And this is specimen A. I do hope that the lighting is pretty much the same. So just to look at specimen A and C, I'm going to be putting them beside each other, just to ensure that we have the same type of lighting and we can make a decision. So that's what's happening there. Just let me switch them around and see if that would be the same thing. Oh, so there's a lighting concern. So if you look over here, you have specimen A. Look at what's happening there. Look at it. Look to the bottom. Probably we'll have to get a ruler and probably measure the height. Let's move this out, and we're going to be looking at this. All right. So I'm going to be pausing the camera for now, and then we are going to come back and see if we can measure the height. All right. So there we have it. The left container is the one with the cold water. The one in the right container has room temperature water. I hope you observed a whole lot. I hope you learned a lot from the video, and you are now ready to write up the lab. Now from your video, you would have seen that the potassium permanganate would have placed at one spot in a beaker, and from there we had it diffusing. Look at the screen, we had it diffusing to other parts of a water column and eventually changing the color of the water from that clear color to a more purple mixture. After you would have had the diagram, then the next step is going to be your observation. And here I have just given you example of what the observation could look like. Now I have bulleted the observation for ease on your eyes. So I said here all three containers had the same amount of solute as solvent. However, the rate of diffusion was different in all three containers. Now all containers had the color of the water changing slowly, moving from that clear color to a light purple, and of course eventually it became purple. However, the container with the low temperature diffused very slowly. The container at room temperature diffused moderately when compared to the slow and the fast, while the container with hot water had diffusion taking place very, very fast. Hence, as temperature increased, so too the rate of diffusion increased, as was demonstrated looking at those three containers at different temperature. You could also document here in your observation the temperature of the water. That must be recorded in your observation, and you need to also record your timing. Those form part of your observation. The discussion, that's what comes after your observation. But your discussion is usually, begins with a background knowledge, and the background knowledge is just a little bit about the content you are covering, and of course probably the importance of what you are covering. So here we said diffusion is the movement of particles from a place of high concentration to a place of low concentration. It is very important for gaseous exchange in organisms. The exchange of oxygen and carbon dioxide is facilitated by diffusion. Then we get on into the discussion of what we saw. We realize that solids are made up of smaller particles. So too liquid. The arrangement of the particles differ for solid and liquids. However, the arrangement in this experiment allowed the particles to move. The process was encouraged by the concentration gradient of a mixture. Hence, the solid moved from high concentration, that is where it was in the bottom, to low concentration, that's the other parts of the water column. The process of diffusion was further impacted by the difference in temperature. As the temperature increased, it provided more energy for the particles to move. Matter is always in motion, and an increase in temperature can speed up the movement of particles, while a decrease in temperature can slow down the movement of particles. Now, I want you to observe that in the lab, I provided no explanation in my procedure. I provided no explanation in my observation. The explanation is provided in the discussion. And you want to ensure that when you are writing up your lab, you are following this procedure. Now, after this discussion, in some cases you will have a limitation. In other cases, you might have the conclusion. For this lab, we have the conclusion coming up after the discussion. Now, the conclusion, you arrive at a conclusion based on what your aim was. So, your aim is going to be answered by what you observe. So, the answer to your aim is actually going to be your conclusion. And here the conclusion is, solid can diffuse through liquid once the particles are loosely fixed. So you wouldn't expect to put some gravel in, of course, a beaker of water and ask the gravel to diffuse, because the particles are not at that level that they will diffuse. Alright? Now, another thing we observe and can answer here is that as the temperature of the mixture increases, so too the rate of diffusion. So you'll remember that we said that diffusion is, of course, impacted or affected by temperature, and you would have seen that demonstrated in all three samples. Remember, you must follow the procedure when writing up the lab. Another important thing to note is that the discussion is something that would have been paid attention to when we are doing the AI lab. So you need to have a good discussion for your analysis and interpretation. Now let us look at what is covered in the limitation. Now the limitation covers those things that would have caused the result of the lab to be flawed, or things that could lead to what we refer to as conformational bias or probably chance result. Now, potassium permanganate was placed in the containers one after the other, from cold to room temperature to hot, and this could have minor impact on the result. Now, why I had to do that despite the guidelines in the procedure said that it must be done at the same time, I was recording and doing the lab at the same time. So anything that could cause the results of your lab to be flawed, that is a limitation that at the time probably you couldn't have corrected. Then of course you want to document it as a limitation, so that the persons who will do the lab after you, they can look at your limitation and make sure that the lab is done a little better, so that the result can be more accurate, should in case it was not accurate when you did it. So the lab got started before we started recording, and you would understand that I had to do that. We are pretty much at the end of this lesson. It went so fast you wouldn't even believe. So you have to replay to ensure that you get it right. I also want you to check the labs for those persons who would have done biology and chemistry and integrated science. Check your lab to see if you have been following the correct procedure. I want you to also liaise with your teacher to ensure that you are getting it right. Now, thanks for watching, and please remember to subscribe, and when you subscribe, click that notification bell to ensure that you are getting all the publication as we release them. I want you to also share the link with friends and family, church members, school, local and abroad, so we can grow this intellectual community. Now please join us on a Sunday at 5 p.m. and Friday at 5 p.m. where we have Biology Live. That is where we take your questions on the topics of the week and where we try to solve some past paper questions. We're asking you questions, we're answering some of your questions so that we can get better at the content as we move forward in the syllabus. Once again, thanks much for watching, and remember to like, share, and subscribe. Until next time, walk good.